The first thing you should know about beta decay is that there are two different types. There's what is known as beta minus decay and beta plus decay. In beta minus decay, the nucleus gains a proton, but the total number of nucleons stay the same, which means it loses a neutron. And as a result, an electron is emitted. This is the electron. And an antineutrino is also emitted. That's what this is, the antineutrino. Oops. And the bar above it is what tells me that it's anti. If you see a bar written directly above the letter for the particle, that means it's an antiparticle. And this, it looks like a V, but it's the Greek letter nu. Now, what's actually happening in beta minus decay is a neutron is actually decaying into a proton and an electron and an antineutrino. And in beta plus decay, you can see instead what we have, the nucleus is losing a proton, but because the number of nucleons stay the same, that means it's gaining a neutron. A positron is emitted. That's what this symbol is. This is a positron. A positron is just an anti-electron. It's the exact same as the electron in all ways, except that it has a positive charge. So instead of a negative charge, it has the same charge magnitude, it's just that it's positive. And then this right here, this is a neutrino. And what's really going on here is that a proton is turning into a neutron and a positron and a neutrino. Now both of these interactions, or these decays, I should say, occur because of what is known as the weak nuclear force, or more commonly just called the weak force. And it's called the weak force because essentially it's weaker than the other forces, most specifically the strong force. It only occurs, or I should say it effectively only acts over extremely small distances, smaller than the diameter of a proton. And it's an odd force, at least compared to the others. The others make things accelerate, but this one changes a fundamental particle, changes the type of fundamental particle. Specifically, it changes quarks. If you don't know, quarks are the fundamental particles that make up protons and neutrons, and they come in there's 6 different types. We refer to them as flavors, 6 different flavors, and the weak force can allow them to change the type or change the flavor that they are. There's no other force that allows a particle to change what it is in this way, not a fundamental particle anyway. And the other thing that's notable about the weak force is that it's one of only 2 ways that the neutrinos, including the antineutrinos, interact with matter. Neutrinos only interact with matter via the weak force or gravity. That's it. And that's part of what makes them so hard to detect, because they have this, they interact so rarely as a result. Okay, so that's beta minus and beta plus decay. There really isn't anything more to say about them. The best thing to do is take a look at a problem here. So what we've got here, if the daughter nucleus in a beta minus decay is beryllium 9, what is the parent nucleus? So I should mention once again, as with alpha decay, this is known as the parent nucleus, and this is known as the daughter nucleus. And so in this case, I know what the daughter is in beta minus, so I know this, and I'm asked to determine the parent. Okay, so we can just see right here that the daughter has 1 more proton than the parent. So consequently, the number of nucleons stays the same. So this is still going to be 9, but the number of protons is going to be 3. If you're not sure what that is, you go down, look at the periodic table. You can see that 3 is lithium. So you come back up here, Li. There we go. That's the answer. And so then all that's left is to put it into Webassign. Okay. So here's how you put it into Webassign. You need to make use of the subscript and superscript. It shouldn't matter what order you do them in. So let's see, we got lithium 9. So that's the subscript. Then I'll hit the superscript tool, lithium 9, and then I'll just type in that I'm doing lithium. And then I just go ahead and submit. Oops. Let's see if I forgot to have the mark show there. There we go. And that's correct. And of course, I hope everybody noted that as I was typing it, it kind of showed me in the window how it was looking so I could make sure it was correct. It looked the way it was supposed to. But that's it. That's how you do this.